BJ, good morning. Because Prempi Kaleshwar, then Shankar, yes, good morning. Then Saurav, good morning. Anushka, Shivshankar, sorry, Shivkumar, good morning. Vijay SK, good morning. Suma KC, good morning. Spurti BR, good morning. Once again, good morning, everybody. Welcome to Pi Academy, the place for mathematics and science. Dear students, in the last class, we were discussing the chapter light, reflection, and refraction. And we were focusing on the second part of this chapter. It is about refraction. The basic information related to refraction is already over, right? It may be the definition of refraction, cause for refraction, then experiment on refraction, and also we come across one of the important term called refractive index with respect to refraction of light, right? Just we shall recall the definition. The definition of refraction is when a ray of light travels from one medium to another medium, it changes its direction of propagation, and we call this phenomenon of light as refraction of light. Then what is the cause for refraction of light? Yes, the velocity of light is different from one medium to another medium. This is the reason why the ray of light changes its direction when it travels from one medium to another medium. So cause for refraction is, it is due to the change in velocity of light from one medium to another medium. Then even we come across the two important laws of refraction of light. Just to recall the first law of refraction, it is, one is incident ray, second one refracted ray, third one is emergent ray. And what do you call the perpendicular drawn at the point of incidence? Normal. At the point of emergence, that is also a normal. According to first law of refraction, the incident ray, the refracted ray, and the normal drawn at the point of incidence all lie on the same plane, right? Then second law, Ashutosh BJ, what is the name of, what name has been given for second law of refraction of light? Not Snell's law, it is Snell's law. S-N-E-double-L apostrophe S, Snell's law. Got it? Snell is different from Snell. Okay, according to this law, the ratio of sine of angle of incidence to the sine of angle of refraction is always constant. What we have called that constant? It is refractive index.
Sir, unmute your audio. Sir, unmute your audio. Unmute your audio.
Refractive index. This will also be defined in terms of velocity of light, in terms of angle of incidence and refraction, in terms of depth, in terms of wavelength, right? These are the different ways, but generally we define the refractive index as the ratio of velocity of light in the air or vacuum to the velocity of light in
given medium.
Then what is the unit of refractive index?
No units.
No units.
Because it is expressed as the ratio of velocities
of different medium
in two different mediums. Then refractive index can also be written as sin I by sin R. It is also equal to real depth divided by apparent depth. Then what is the refractive index of air? Here on my screen. Yes, 1.0003. Refractive index of water, 1.33. Refractive index of glass,
1.5.
1.5. Refractive index of diamond,
2.42.
2.42. And we also know the meaning of these if I take an example of refractive index of diamond is 2.42, it means the velocity of light in diamond is
2.42 times less
2.42 times
than
less
Then
than the
velocity of light
less
in
than
air or vacuum.
velocity of light in air or vacuum.
yes, in air or vacuum. Then even we have defined another important term called absolute refractive index. Yes, Prem, you tell what is absolute refractive index? Air or vacuum? It is vacuum. If you go for finding the refractive index of any medium with respect to vacuum, then it is called absolute refractive index. It can be defined in two different ways as the ratio of velocity of light in vacuum to the velocity of light in the given medium, or the refractive index of the medium with respect to vacuum is called absolute refractive index. When light ray travels from rarer medium to denser medium, whether it bends towards the normal or bends away from the normal,
towards the normal.
Towards the
Towards
normal.
the normal.
towards the normal. Then as it travels from denser medium to rarer medium, it bends
Away from
Away
the
from the
normal.
normal.
away from the normal. Then after that, we come across the transparent material which has at least one curved surface called
Lens.
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 There are two types of lenses. One is
Concave lens and convex lens.
what do you call a lens in which the refracting surfaces are bulged outward?
Convex lens.
Convex lens.
Convex lens.
Convex lens. In this, the middle part is thicker than the edges, right?
Sir.
Then the lens in which the refracting surfaces are bulged inward
Concave lens.
Lens.
Concave lens.
is called concave lens, in which the middle part is thinner than the edges. Which of these two is converging lens?
Convex lens.
Convex lens.
Convex lens.
Convex lens is called converging lens because the rays of light actually meet at a point after the refraction through the lens. Got it? And concave lens is called diverging lens.
Diverging.
The reason is the rays of light appear to meet at a point after the refraction through the lens. So these are the two important points, and we have discussed this much in the last class. So now we'll move on to the next part of this chapter. In the next part, we will focus on the terms associated with lens, like in mirror. Mirrors are little ade riti lens allu kuda. And before that, I think I had given you the heading and to write the explanation yourself. Written up.
Yes, sir.
If you are telling yes, what was the heading? Yes, converging lens and diverging lens. This was the heading. Not written, just copy. Converging and diverging lenses. Here, we all know that convex lens is called converging lens. So write that point. Convex lens is called
Sir, excuse me.
converging lens. Please go on writing with me. Convex lens is called converging lens because the rays of light meet at a point after the refraction through the lens. Convex lens is called converging lens because the rays of light meet at a point after the refraction to the lens. Okay, draw the figure as well. Not. If not, just this one. Very simple. Draw a straight line. Draw a perpendicular line of length about 4 centimeter. 2 centimeter above the line and 2 centimeter below the line. Then you will use or you may use even compasses also. Then draw the rays of light. Just few rays of light. This is first one and the second one, third one, fourth one. These are the 4 rays of light coming from the source. They incident on the lens, and these rays undergo refraction as they travel from one medium to another medium, and they meet at a point. So this is the rays meeting point. Without failure to show the direction as well. Okay, finished. Next. Another point regarding concave lens. We all know that concave lens is diverging lens. Concave lens is called diverging lens. Diverging lens because the rays of light appear to meet. The rays of light appear to meet after the refraction to the lens. After the refraction to the lens. Next, for this also, let's go for drawing the figure. First, draw a straight line. You can mark every 2 centimeters. Then draw a perpendicular line at any one of these points. Here also, I am drawing the line of length 4 centimeter, 2 centimeter above the line and 2 centimeters below the line. Then from this perpendicular line with a distance of 4 centimeter, the radius very close to the perpendicular line, you can draw like this. Similarly, from this point, from 4 centimeter with this distance and line and arc.
Raju sir, can you hear me?
Yes, sir.
Great, sir. Dheeraj, Mohammad Faisal, Pratham GR. Dheeraj, heavy sound coming from your side. This is a final warning. Mohammad Faisal, can you hear me? Mohammad Faisal,
Yes, sir.
unnecessarily don't unmute. Unnecessarily don't unmute. Sir, continue.
Okay, sir. Now draw the rays of light coming from the object or coming from the source incident on the lens. We all know that these rays undergoes refraction and the refracted rays diverge from each other. They start moving away from each other. And when they are extended on the same side of the source of light, they appear as if they are coming out from a point. So I'm going to mark that point here. This is the point. Then from here, draw the rays. Dark ray indicates the refracted ray, and the dotted line, that ray indicates it is extended. Continue. From the same point, another extended ray. Here as well. Now, this point is called diverging point of the point at which the rays of light appear to come out from the point. It is diverging point. In case of convex, show this point. This is point of convergence or converging point. Converging point. Where the rays of light actually meet after the refraction. Converging point. Over. Over. Now we are moving to the terms related to lenses. Right, the side heading. Side heading. Terms. Terms related to. Terms related to lenses. Just observe. Stop right here. Just look at it. Now, could you tell what type of lens it is? Convex.
Convex.
Because
Convex.
Convex lens.
reason is the refracting surfaces are bulged outward. The middle part of the lens is thicker than the edges. Similarly, this is the lens whose refracting surfaces are bulged
Concave lens.
inward. It is called concave lenses, whose middle part is thinner than the edges. Look here. Observe, this is the refracting surface, right? And even this is also refracting surface. they look like an arc. Now let us go for extending each of these arcs. What you will get? You get
Circle.
Sphere.
when you
Sphere.
imagine
Sphere.
it as a three-dimensional figure, then it will be
Two
a
spheres,
sphere.
sir.
And similarly, this arc also is to be extended.
Two spheres, sir.
There are two imaginary spheres. In the same way, here as well. Look, this is a concave lens, and these
Asks are
is
coming.
a refracting surface. Refracting surface. And let us go for extending these refracting surface. Again, we will get
Sandeep GS, are you, where are you? Are you in
imaginary
Dubai or
sphere.
Sudeep GS? Unnecessarily don't unmute your audio. This is the final warning. Sir, continue.
Okay. From these two figures, can we say that either convex lens or concave lens, these are the parts of two imaginary spheres?
Yes, sir.
Yes, sir.
Okay. So this is the convex lens, which is whose refracting surfaces are the parts of two imaginary spheres, and both the imaginary spheres are transparent. Concave lens, the surfaces of or the refracting surfaces of concave lens are the parts of two imaginary spheres. In general, lens is a part of two imaginary spheres. Just remember that. Now, if it is formed by two imaginary spheres, then these spheres will be having the centers, right? There are two centers. In case of mirror, we have got only one center. But here, two imaginary spheres are there. They are having two centers, and these centers are called
Center of curvature.
curvature of a lens. There we used to, in case of mirror, we were using the word center of curvature. But here we have to use centers of curvature. The centers of two imaginary spheres of which the refracting surfaces of a lens are the parts. Clear? Definition is so simple. Centers of two imaginary spheres of which the refracting surfaces of a lens are the parts. And we will name these centers as C1 and C2. Here also, this is C1 and this C2. They are the centers of curvature of concave lens. These two are centers of curvature of convex lens. Then what do you call the radius of imaginary spheres?
Radius of curvature.
Radius of curvature of lenses.
Two spheres are there. Then obviously we'll get
Radius of curvature.
you all know that
Radius of curvature.
Radius. Yeah. Look at this is the radius. I call it as C1A. Radius of the first imaginary sphere, and C2B. From C to B, it is radius of curvature of second sphere. So these two are radii. The radii of two imaginary spheres of which the surfaces of a lens or its parts are called radii of curvature. Similarly, there also I go for marking. This is a radius of curvature C1A. Next, and C2B. This is also a radius of curvature of concave lens. Clear? Next, let us go for imagining a ray of light that passes through centers of curvature. What it is called?
Principal axis.
Principal axis.
Principal axis. So this is also principal axis. The ray of light, or the imaginary ray that passes through centers of curvature of a lens is called
Principal axis.
principal axis. And here also I am marking this is principal axis. Now, look here. These are the vertices of concave lens, convex lens. And now let me go for joining these points of these vertices. And we call this as the diameter of the lens. Don't say diameter of the imaginary space. It is the diameter of a lens. And we call this diameter as
Aperture.
aperture. Or even here, this is the diameter of a concave lens is called aperture. Observe this aperture and principal axis both have intersected at a point, and that point is inside the lens. And this is called the geometric center of the lens. And this
Optic
geometric
center.
center of the lens is called
Optic center.
optic center. Optic center. Once I repeat, the point of intersection of the aperture and the principal axis lie inside the lens. This is the midpoint of the lens, also called the geometric center of the lens. So this geometric center of the lens is called optic center. Even here also, this is optic center. Optic center will always be inside the lens. And another important point is the ray of light which incident at the optic center, it passes through the lens without bending. You know why? The ray of light which incident at optic center, this will be perpendicular to the surface of the lens, refracting surface of the lens. So when it is incident perpendicularly, then angle of incidence as well as angle of refraction will be 0. So that is why it passes through the lens without bending. Not only that, even in case of concave also, the ray of light incident at optic center passes through the lens without bending, because the angle of incidence is 0, even angle of refraction. Or else the ray of light incident on the surface of the lens perpendicularly. Got it? So still few more terms are there. So before going to those terms, first we will go for writing the information regarding these points. Right? Finally, related to lenses in that first one is centers of curvature. Centers of curvature. Right, the definition is so simple. Right. The centers of two imaginary spheres. Imaginary spheres of which the surfaces of nothing but refracting surface the surface of a lens the parts are called centers of curvature. Centers of curvature. And just below that, you go for writing this. Don't go for drawing. Afterwards, we'll draw that. And in that figure, we will show C1 and C2 are the centers of curvature. C1 and C2 are the centers of curvature. Second. Right. Radii of curvature. Same definition. In place of centers, we will write radii. Right. The radii of two imaginary spheres. Two imaginary spheres of which the surfaces of a lens are the parts. The radii of two imaginary spheres of which the surfaces of a lens are the parts is called radii of curvature. Radii of curvature. What do you call the imaginary line that joins centers of curvature of a lens?
Principal
Axis.
Principal axis.
So the principal axis can be extended on either side to any distance. There is no limited. Third one, it is principal axis. Radii. What are the radii which I had marked earlier? It is
R1 and R2.
A and C2 B. C1A and C2. Third, principal axis. The imaginary line that joins RS group.
Pawan Kumar BL.
Plus joins centers of curvature of a lens is called principal axis. Well, now let's go for drawing both convex as well as concave lens. So just first go for drawing a straight line. Could you tell what does this straight line indicate with respect to lens?
Principal
Axis.
Principal axis. Just go on marking for every 2 centimeters. 2 centimeters. Now, at this point, let us draw line. Let it be given 2 centimeters. 2 centimeters above the principal axis, 2 centimeters below the principal axis.
Everyone, please turn on your video. Everyone requesting, please turn on your video.
Okay. From this point, from this point, I am taking the radius more than 2 centimeters. You draw a circle. And the circle, it should be in dotted line. Only the surfaces of a lens should be darkened. Even this side also, without changing the radius, this point and center. Draw a circle.
Anchal MK. Anchal MK.
Show the dotted line, which indicates the imaginary space. Next, name this as C1, center of curvature, and C2, it is second center of curvature. And C1 to A, this is radius. C1 to A, and C2 to B, it is another radius. Here, let me show you the radius of curvature. It is denoted by capital R, C1 to A, and C2 to B. Even this is also capital. Similarly, draw with respect to concaves. Draw a straight line. And go on marking for every 2 centimeters. 4 centimeters. Draw a perpendicular line. Then use compasses. Take the radius less than 2 centimeters and draw a circle. Draw a circle.
वालेकुम सलाम।
Shayan CM. Shayan CM. Shayan CM.
Your students, if unwanted sound is coming from your side, please mute the audio. Some height you can just draw the horizontal line. And here also you have to show the dotted line. And mark it. C1 is the first center of curvature of lens, and C2 is the second center. C1A is the radius of curvature. C2B, radius of curvature. Radius, let us denote this by capital R. From here to here, and here also capital R. Over. Next, let us write fourth term. Over. Observe it. What do you call the diameter of the circular faces of a lens? It is aperture, right?
Aperture.
Aperture. Aperture. Right. The diameter of circular faces of a lens is called aperture. Here I am going to mark the aperture of convex lens as M dash, and this is concave N dash. Just right. M dash and N dash. These are nothing but the refracting surfaces only actually. In case of mirror, we used to take the reflecting surface. Here we are taking the refracting surface. What do you call the point of intersection of principal axis and the aperture? It is optic center, also called optical center. Right. And it is also defined as the geometric center of the lens. Fourth one. No, fifth one. Optic center. Optic center. Right. The geometric center of the lens. The geometric center of the lens is called the geometric center of the lens is called optic center. And usually it is denoted by the symbol O. Right. It is denoted by the symbol O. And we also know that it is the point of intersection of principal axis and the aperture. It is the point of intersection of principal axis and the aperture. And we also know that it is always formed inside the lens. It is always inside the lens. And we also know that the ray of light incident at optic center passes through the lens without bending, because angle of incidence will be 0. Then at what angle the ray of light incident? 90 degree. Angle of incidence will be 0. But the ray of light incident on the surface of the lens at right angle. Our matra angle of incidence and angle of refraction both will be 0. Right. When a ray of light incident at optic center, it passes through the lens. Without bending. Because I equal to 0 and E1 are equal to 0. Stop. Now let us show the optic center of both convex and concave. Draw it simply. Now, simplest way. Draw two horizontal lines which indicate principal axis. When we draw the perpendicular line, what does it indicate? Aperture. Next, take protractor. Draw the convex lens, then let us draw concave using the protractor and the compasses. Whichever you feel comfortable, you can go for using. What? First one is convex lens, and here this point is called optic center, and here this point of intersection of aperture and principal axis is optic center. The ray of light incident at optic center or in the direction of optic center. This ray passes through the lens without bending. Here. Finished up. Pratiksha DG, have you finished? Continue. Sandeep, finished? Okay. Adya, Disha GA, Varsha HR. Go on copying with me. It will be easy to finish along with me. Vijay. Finished. Over. Please observe it. Don't copy anything. Just look at it. What it is called?
Principal axis.
Principal axis.
Aperture.
Aperture. Convex lens.
Convex lens.
Convex lens. At this point,
Optical.
Optic center.
Optic center.
see that this is the ray of light incident in the direction of towards optic center. And when you observe this ray with respect to surface of the lens, lens is 90 degree. Got it? This is 90 degree. And here, when it incident at optic center, it passes through it without bending. See that the normal is drawn here. This normal and then the incident ray, they coincide with each other. When both they coincide with each other, what is the angle of incidence? 0 degree. Even
0
angle of reflection
0 and 0.
will also be 0 degree.
0 degree.
Yeah. The next term is, wait. Principal axis, aperture,
Convex lens. Optic center.
These are the parallel beam of light or parallel rays of
Reflex.
light incident on the lens.
Sir,
The ray of light which incident, 2 times it undergoes refraction. But for the ray diagram, we will show the rays of light incident at aperture. On the aperture, ray diagram. Actually, refraction once, it is once, then twice. Okay. These are the rays of light incident on the lens parallel to the principal axis. These rays undergo a refraction, and these emergent rays will meet at a point on the principal axis, and we call this point as
Converging point.
focus.
converging point, also called principal focus of
Principal focus.
convex lens. Like in mirror, ali kuda principal focus ittu alva. Here also principal focus. Look here. The point on the principal axis where the rays of light actually meet after the refraction through the convex lens is called principal focus of convex lens and is denoted by F. But as the lens is a transparent material, light ray can also come from the right side. Is it not? Here we'll get principal focus. Got it? So it has two principal foci. Plural of focus, foci. Got it? But in case of mirror, we'll be having only one principal focus, lenses, two principal foci. Got it? Foci You can use it as, you can read it as foresight. Similarly, I'll go for taking another one. What is this?
Principal axis. Aperture.
Curvature.
Convex.
Convex
Concave
lens.
lens.
Convex lens.
Concave lens.
Concave lens.
Concave.
Here,
Concave lens.
the wave of light of rays of light incident on the lens parallel to the principal axis. These light rays get
Reflected.
refracted and the refracted light rays move away from each other.
Divergent.
Divergent.
When these light rays are extended on the same side, they meet at a point on the principal axis. Then we call this point as diverging point.
Diverging
It is
point.
also called principal focus of
Focus.
concave.
Concave lens.
Actually the rays of light will not meet after the refraction, but they appear as if they are meeting at a point when the refracted light rays are extended on the other side. Clear? Let me
Sir.
explain the definition. The point on the principal axis where the rays of light appear to meet after the refraction through the lens is called principal focus of concave lens. But generally, we define principal focus of lens as the point on the principal axis where the rays of light actually meet or appear to meet after the refraction through the lens. Clear? Is called principal focus. We can also define one more term. Okay. What is this? Optic center.
Optic
This
center.
is principal focus. Distance between these two. It is called
Focal length.
focal length is the distance between optic center and principal focus of the lens. Next, here, this is optic center and is principal focus. Here also, focal length. Focal length may be found out on either right side or the left side.
Left side.
What are the signs, sir?
Now, focal length of a lens. I think find out what are those.
By the relation R is equal to 2F.
No. I'm mirror here. Now, let me explain. Listen. Assume that this is an experiment table. Experiment table. And
Raju sir. Raju sir.
yes, sir.
Gautami L had a problem, sir. I think she had a doubt. Please ask her, sir. Gautami L.
Gautami L. Gautami, can you hear me?
Yes, sir.
Yes. What doubt you have?
Nothing.
Glass. Gautami, do you have any doubt?
No, sir.
No. Observe. Stand. V shape of it now. Both online and offline classes are going on. Difficult to show the experiment. First, I'll go for explaining it. Look it. This is, assume that it is a screen. Then here you are going to use a lens stand here. lens time. And that you are going to place a convex lens and you'll try to focus the distant object. You'll get you try to get the image of the tree, not inside tuition room, outside. You want to focus on the screen. So very simple. Just you'll go for to and fro motion of this style, and then you'll get the image of that tree on the screen.
Inverted.
Followed. So here the rays of light coming from the tree incident on the lens, and these light rays meet at a point on the screen, and we call this point as principal focus. Principal focus, and this is the optic center. Now we will take the distance between this image and the lens as focal length. This is how we find out the focal length of the lens, by focusing the distant object, not nearby, distant object on the screen. We'll find out the focal length. Okay. See, this is the iron stand. Sorry. Lens stand.
Stand.
Lens stand. Lens stand. And we have to place the lens like this. And here we'll go for placing the screen. By placing the screen, just by moving this lens, we will go for getting the image of the object on the screen. Got it? Hope that you are able to see. Answer. Can you see this image? In mobile is there. I'm catching the image of this picture. Tushar is there. Then Sanchara is there. Next, Rajat or Kesri. These three students. Can you see the image?
Can't see image.
No, sir.
Me can't see the classroom.
Sir.
Now we are getting the clear image. Okay. Hold on. Class, offline class coming, sir. Raja. Definitely, I'll conduct this experiment. Many are there, not only this one. This is how we find out the focal length of the lens, convex lens. Concave lens length find out. How do you go for finding? Same only. No, try more. Is it possible to catch the image? Where the image is found? It is inside only.
Inside. Yes, sir.
Yes, sir. We can see window.
We can see, sir.
You can see, no?
Yes, sir.
Yes, sir.
Yes, sir. When you calculate, how do you find out the focal length? Just think over it. I will not explain more. Now, you just go for copying these two terms. One is principal focus, second one is focal length. Sixth term, no? Last term was
Optic center.
Then seventh. Right. Principal focus. Principal focus. Right. The definition as the point on the principal axis point on the principal axis. Point on the principal axis where the rays of light actually meet, where the rays of light actually meet or appear to meet after the refraction through the lens is called Samudra. Copy this. It's called principal focus. Principal focus. So in bracket you may write, it is denoted as F. And right, foci is the plural of focus. Next, the seventh one, it is focal. Right. Focal length. Focal length. Right. The distance between optic center and principal focus of a lens is called focal. It's called focal length. In bracket you write smaller. It is also denoted by smaller. Now we'll go for showing both principal focus and focal length. Just follow my instruction and draw the red eye. Draw a straight line. Draw a straight line and go on marking for every 2 centimeter. It is 2, 4, 6, 8. Then after 4 centimeter, you draw perpendicular line. Its length should be 4 centimeter, such that 2 centimeter above the principal axis and 2 centimeter below the principal axis. Over. Next, take compasses from this initial point. At a distance of 4 centimeter from this aperture. Take this pointer center and the top of the perpendicular line as radius. Here it is. It comes meeting. We draw an arc. Similarly, from this point, draw that. Next, draw the rays of light. Rays of light. Incident on the lens parallel to the principal axis. Show the direction as well. First point is this point. Let all the light rays pass after the refraction. Right. Yeah. This is O. And also show the distance between these two. It is focal. Focus is denoted by the symbol F. Let's start. If focal length double from here to here, and this is to be written as 2 and 3 times Thornton. This is 3F, then 4F, 5F, like that. But in case of mirror, we were taking P, F, C, then beyond C and arithmetic outside. Here, F, 2F, 3F, and so on. Even on the other side also, you can go for marking. It is F, again, 2F. Next, let us draw concave lens. Actually, I am speaking. You are speaking. Very good. Right. Go on marking for every 2 centimeter. Two, 4, 8, 10. Stop. Here also. Draw a perpendicular line. Again, Patel, finished. Anaga, have you finished this? Oh, copy that, copy. Just listen to, listen. What do you call this horizontal line with respect to the lens?
Principal axis.
Principal axis.
Perpendicular line?
Aperture.
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 What do you call this point? F?
Focus.
Focus.
Focus. Principal focus. This is 2 times.
Center.
3F. And here also. F.
2 times.
2 times the focus.
Now, with the 2F as center and the radius just less than the distance from 2F to this aperture. See, I take only this much. Draw an arm. Over. Similarly, with the 2F as center on the another side, without changing the radius, draw one more. CBSE Nagasamudra. Finished, huh? Gagandeep. Over. Swaroop KS. Swaroop KS. Swaroop, can you hear me? The idiot fellow is busy in talking with others. Swaroop, can you hear me? Have you copied this? No, I think not. Now let me show the rays of light. The rays of light coming from the object incident on the lens parallel to the principal axis and be shown the show the direction as well. And these rays get refracted and the refracted rays are extended on the same side of the object. They appear as if they meet at a point on the principal axis. And we call this point as principal focus of concave. And show the direction. Direction of these refracted rays. Mark the optic center. Next, focal length. It is the distance between optic center and principal focus. Optic center and principal focus. Hope that you all have copied this. So these are the important terms related to lens, starting from center of curvature up to focal length. You must practice among these optic center, principal focus and focal length. These are most important terms. You must learn them. And one more information. Look here. Assume that let us go for taking the ray of light which moves along the principal axis. Does it undergo refraction?
No, sir.
Yes, sir.
No. What is the reason?
Because the angle of
It's
incidence is 0
perpendicular.
degree.
Perpendicular to the lens.
Perpendicular to the surface of the lens. Then what will be the angle of incidence?
0.
0 degree.
0 degree.
Refraction,
0 degree.
right? Once I tell the ray of light which moves or which travels along the principal axis, it passes through the lens without bending because it incident on the surface of the lens at an angle of 90 degree, or angle of incidence and angle of refraction will be 0 degree. Dear students, like in mirror, here also we will go for describing the characteristics of image formed by the lenses. Could you tell what are these characteristics? First one is nature, second one is
Nature, size,
size,
position.
Size,
third one is
position.
position. What are the terms related to nature? Virtual,
Real,
Inverted,
virtual,
and
inverted,
inverted,
erect,
okay. Real ಬರ್ಬೋದು ಅಥವಾ
virtual.
ಬರ್ಬೋದು, or else erect image, then inverted.
Inverted.
Size either
Highly magnified,
Diminished or
diminished,
Finish.
highly magnified, highly diminished,
diminished.
diminished.
or
diminished
equal.
or
Magnified, magnified, diminished.
One more The
Both,
point,
sir.
Same size as
Same
the
as
object.
the object.
point image. These are the possibilities. Once I remind you. Magnified or highly magnified. Then or diminished or highly diminished or equal size or point image. So these are the possibilities. And the position of the image, it all depends on the position of the object.
Object.
But where the object should be placed. If I take, assume that we are taking the convex lens, then we can go for placing the object in these places. Can you tell what is the place of the object in front of the?
Between the focus and the optic center.
Principal focus.
It is between optic center and principal focus. Next,
On principal
At
focus.
The
focus.
focus.
focus or at F. Then
At
Between
2F.
the focus and
Between
the
F
2F.
and 2F.
Center of curvature.
center of curvature and
Optic center.
okay, it is focus, first principal focus, and this is second. So we have placed the object between F and 2F. Now here at 2F,
2F.
2F.
Beyond 2F.
2F.
F and infinity. Beyond 2F.
At infinity.
At infinity.
At infinity.
these are the places where we go for placing the object in front of the lens. So based on that, we will go for describing the characteristics of image. And here also, in case of lenses also, we will go for following some of the rules. Let us move on to that. Right on, the side edge. Side edge, it is the rules used for rules used for drawing rules used for drawing the ray diagram. Drawing ray diagram to represent the formation of image. Formation of image by the lenses. Formation of image by the lenses. So, in case of mirror, how many rules were followed? 4 rules.
Four rules.
Three rules are there. Let us move on to these 3 rules. So the table. In that, first column for convex lens and second column for concave. First one for convex lens and second one for concave lens. Then, rule 1. Draw the lenses. One marking for every 2 centimeter. Finished up. The first ray is the ray of light coming from the object incident on the lens parallel to principal axis. This ray passes through focus on the other side of the lens. Next, with respect to concave, the ray of light coming from the object incident on the lens parallel to the principal axis. This ray appears as if it is diverging from a point on the same side of the object. Object ಯಾವ ಕಡೆಗೆ ಇರುತ್ತೋ ಅದೇ ಸೈಡ್ ಇಂದ ಫೋಕಸ್ ಇಂದ ಬಂದಿರೋ ರೀತಿ ಕಾಣಿಸುತ್ತೆ. This is the first one. Over. Okay. Listen. You may stop drawing. Stop drawing. Because it's already time up and it will be continued in the next class.
Thank you, sir.
Listen. Tomorrow you will be having weekly test. Weekly test timing from 6 to 7:30 as usual. And the syllabus light chapter only up to here. Got it? Light chapter up to here. I think in the last week I had given you up to laws of reflection of light, right?
Yes, sir.
Ray diagram.
Sir.
Okay.
ಕೊಟ್ಟಿದ್ರಿ sir.
I think it is with respect to between pole and principal focus and at focus. We had concentrated only on that. Now let us do one thing. The ray diagrams related to the formation of the image by mirrors from there up to here. Okay. Timing again I've been telling morning from 6 to 7:30. 6 to 7:30. Okay, with this, let us stop the class. Thank you very much.
Thank you, sir.